Hello everyone. So I've decided to make a video on the distance equals rate times time application problem that we have in our MyMathLab. So I'm going to start off, first of all, we've got a few things going on, right, in this problem. We have Carl rowing for 4 hours with a 5 kilometer per hour current to reach a campsite. And then we have a return trip against the same current that took 9 hours. And we want to find the speed of the boat when Carl rows it in still water. So, first of all, before we even start, let's talk about it. Let's model it, okay? Modeling is always a really good idea. And what I mean by modeling is basically just draw a picture. So I'm going to start off with a point, and I'm going to call this point the start. Okay? And I'm going to call the other point down below, I'm going to call that the campsite. Because that's what we have going on in this problem, right? And I'm going to pick a nice blue color and maybe a bigger point. And I'm going to say, well, this river goes down to the campsite. Okay? Maybe fill that back in a bit. So, what do we know about rivers? Well, rivers flow in one direction, right? So if I'm starting up here at the north, this top part, and I'm headed down south towards the campsite, I know that my 5 kilometer per hour current is a positive number. Okay? Because I'm traveling this way with the current to the campsite. The other thing I know is that when I'm going back in the other direction, okay, when I'm going back up, I know that this is a negative value, right? It's going to be negative 5 kilometers per hour because you're having resistance against you, against that flow of the river. What else do we know about this thing, right? Let's think about this. Well, what about the distance between the start and the campsite, right? This overall distance between the 2 points, right? That's not changing, is it? I mean, if I go one way down the river and I go back up the river, that length of the river is always going to be the same. So D is a constant. And even when I find the rate times the time to find the distance from the start to the campsite, from start to camp, that is going to equal that distance. And I go backwards from the camp to start, that's going to be the same distance. These are the same length. Those are all really useful things to know here, okay? So let's think about what we don't know. Right? We know a lot. We have a lot of things that we know. We don't know the distance, but we don't really need to know that. It's not really important. It helps us later on when we want to relate these two things together, okay? So let's think about this. Carl is traveling his rate. What does that equal? What is Carl's rate? Well, that's the thing they asked us to find, right? We want to know his speed. Rate can be thought of as the speed. Okay? Another thing we can think about is that if I have a rate, in this case it's kilometers over hours, and I want to know the distance I would move at 5 kilometers per hour, I would have to multiply by some distance, or some time in hours. Okay? Well, this could be anything. This could be any number. But for us, those numbers are going to be 4 hours and 9 hours. One's going to be one way, and one's going to be the other way. Okay? So let's start with the start one. Okay? So let's think about Carl's rate as just a big old R. All right? That's how fast Carl is traveling all on his own in still water. But from start to campsite, right, from the first part of this, we're going with, I'm just going to shorthand it as camp. We're going with the current. This is all with the current. Okay? So we're not just traveling at Carl's rate. We're traveling at his rate plus the 5 kilometers per hour. Because it's added on to the speed. That water is pushing us along with us pushing, or Carl pushing the boat. The next one we have, right, is camp, which I'm shorthanding again, to start. Now we're going to go the other way. From camp to start. And in that case, we are subtracting 5 kilometers an hour because, well, we're traveling at the rate Carl travels, but the river is pushing against us at 5 kilometers per hour. So this is our new rate for each one. You may be wondering how this helps us. Well, it helps us because I'm going to erase the 4 hours and the 9 hour highlighting, and I'm going to go back and I'm going to say, well, we know the return trip, right? Which is the campsite to start, going back up the river. That took us 9 hours. 9 hours. So here, we're going to say times 9. But on the other side, when we went from start to camp, we were at 4 hours. And we were with the current, right? Going to the campsite. So, that's a 4. I should probably mention, and I probably should have mentioned it earlier, that we are using the distance equals rate times time, usually written like this actually, formula. Distance equals rate times time. Now I'm using capital letters instead here because I used lowercase letters for Carl's rate. That's why I made it an R. So here I have one rate. This is the rate to camp. And another one I have the rate to start. All right. I'm not going to keep the sub S's and sub R's. I just wanted to illustrate that these are in 2 different directions. Okay. What we do know though is since we have a rate times the time on both of these, that is going to equal distance. So here, these equal the distance. Whole lot of D's there. But these distances are the same, right? So I could say distance equals 4 times R plus 5. And I could say the distance equals 9 times r minus 5. And I have two different sets here. I have one for start to camp, and I have one for camp to start. But those are the same D. Those are the same D. So both of these things, 4 times r plus 5, equals 9 times r minus 5. So now we just have one variable. We've gotten rid of the D. Realistically, it was unimportant to know that. We could find it later if we wanted, but it's not necessary for the problem. Now we're just going to have to do some distribution. We're going to distribute a 4 to the r, and we'll get 4r. And we'll distribute 4 to the 5, and we'll get plus 20. And we're going to say that that is equal to 9 times r, which is 9r, and 9 times negative 5. So it's a negative and a positive, so it's going to be negative. And then 9 times 5 is 45. We are so close to having a solution now. So here we go. I think it'll be easier to take the 4 away from the 9. So we're going to say 4r minus 4r, and 9r minus 4r. Here on the left, it cancels. That leaves us with 20. On the other side, we have 9r minus 4r, which gives us 5r, minus 45. We almost have r by itself. So we're going to add 45 and add 45. Okay? And that will give us 0 here. And over here on the other side, it gives us 65 equals 5r. Now, you may not like the way 65 equals 5r is set up. You might like the r on the left, so I'm going to go ahead and do that on here on the right. But it doesn't matter which way you do it. If I divide 5r by 5 and 65 by 5, I'm still going to get the rate equals 13. And over here on the left, I'm still going to get the rate equals 13. So, we now know that Carl's rate of speed, the speed of the boat in the still water, is now 13 kilometers per hour. Now, does that make sense? Right? Well, we could prove it out. We could take that 13 and we could add 5 to it on the left side and multiply it by 4 and see what the distance is. Now we know, because we know the r. Right? So let's try that really quick and see what happens. Distance equals the rate. And this, we'll call this one the distance from the start campsite. Start to campsite. So that's going to be 5 plus 13. Times the time, which was 4 hours. And that's going to be 18 times 4. And what is that? That is 72, I believe. 72 kilometers. That's quite a distance. Now let's try the other one. Distance equals 13 minus 5 times, what was that one? It was 9. 9, that's right. So 13 minus 5 is 8. And 8 times 9 is 72 kilometers. So we've checked our work. And we know that this is definitely the correct answer to the problem. Now, I hope you found this video useful. And if you'd like to post some comments, let me know what you think. I'd appreciate it. And I'm going to go ahead and post this on our discussion board. So comment there, comment here, whatever you want to do. Have a great night. Talk to you later.